What's going on, everybody? Mr. Diamond, and this is the follow-up to the video I did earlier. Earlier we did name to structure. Now we're going to be doing structure to name. So this is going to be a little bit more complex. I'm going to have a couple of colored pens as the usual, so I can label things and we can make sure that we're kind of clearly denoting everything as we go through it. Just like last time, I highly recommend you pause the video. These are the three that we're going to do. There's going to be a brief break in between each one of them as I transition to the next structure. So if you want to watch the first one and then go to the other ones by yourself, you can also do that. In the meantime, though, we're going to go ahead and start. I'm going to assume you paused if you wanted to pause. So looking at our first structure. First, it is important to note that this is an NH2 and this is an NH2, so they do not count. I repeat, do not count towards our parent chain. So our parent chain in this case is going to be these bad boys right here. So those guys right there. So that's 1, 2, 3, 4, 5 carbons. And then we also, not just having normal carbons, but we also have this guy right here is 1 double bond. So we would call this a pentene, not to be confused with the hair care brand. Then we've got on carbons here, here, and here, but we need to figure out what way we're going to number it from. So if I were to number it from here, I would have 1, 2 on position 3, and then I would have a 1, 2, 3, 4, 5. So I did this, I would have something on position 1, something 5, and then remember we number based on where the first part of the double bond is, so this would be something on 3 and 3. If we numbered from the other direction, 1, 2, 3, 4, 5, we would have something on position 1, 2, and 3. So we're actually going to number from this direction because that will put our double bond starting on carbon number 2, which is earlier than if we did it here, it would be starting on carbon number 3. So this will be on carbon number 2. Let me get my pink in here again. And then we're going to just go through and we got to identify the other 3 pieces. So we've got 1, 2, 3. So I've got 3 amines. So we're going to have, okay, good, that's showing up on the page. So it's going to be 1, 3, 5 triamine. And then the last thing we need to do is we need to actually identify what type of double bond this is. Because it's not symmetrical on one of the sides, we have to use either cis-trans isomerism or EZ configuration. I don't know if I've clearly said it in class or in the other video yet. I'm not sure. So I'm just going to make sure I say it right here, right now, very clearly. You have to use one or the other. You cannot do a mix of cis-trans EZ. That is not a standard practice in organic chemistry. You want to use one or the other. So looking at this one, because I have a side that has more than one piece to it, I cannot just use cis-trans isomerism. So I'm going to have to use E or Z. So looking at this side over here, this group, let me get yet another color. Looking at this side of the double bond, there's a hydrogen here, and then this piece right here would have a higher priority because it's a carbon. And then on this side, nitrogen has a higher atomic number than carbon, so nitrogen would win over here. These guys are on the same side, or the same side, so it's going to be a Z configuration. Now, since there's only one double bond, we don't have to put a number with it, but it's probably good practice to put that number with it. So we've got a parenthesis 2Z. The amines modify the ending, so we're going to have to put them at the end. It's going to be pent-N, and then instead of that E, we're going to have triamine. And then we need to have a 2 in here to tell us that it's going to be 2 on that double bond. So we're going to do 2Z pent 2 ene 1 3 5 triamine. So, double checking the name, on position 2 there is a double bond, and that double bond is Z configuration. On positions 1, 3, and 5 there are amines. 5 bonded carbon otherwise. Okay, you can see there's a lot more going on here. You do want to be very careful while you're using this, though, that you don't accidentally hide the structure that you're looking at. So make sure that like you are kind of very clearly identifying the stuff that you're talking about there. Okay, looking at the next one, we've got a 1, 2, 3, 4, 5, 6, 7 carbon chain. We've got 2 double bonds. And if we look at numbering for this, this one has a double bond starting on number 1. This one has it on something starting on 1, 2, 3. So we're going to number from this direction. So I'm going to do 1, 2, 3, 4, 5, 6, 7. So it's on carbons number 1 and carbon number 4. So this will be hept. So it'll be 1, 4 diene. So that gets us our parent chain out. Now we just have the other pieces hanging off. So we've got these two. That's 2 methyl groups. It's on 4 and 5. So that'll be 4, 5 dash di, because remember you have to include the fact that it's 2, so it'll be dimethyl. And then that only leaves, what other color I got? There we go. That only leaves this guy right here. So that is on position number 3. There is a ketone. So that means our ending is going to change to 3-one. Now, just like before, assemble it all together. Make sure I have this blocked off so I don't accidentally include stuff from the other one. Oh, wait, almost forgot. Also very important. We have double bonds, but we need to identify types of double bonds again. This first one has something symmetrical, so we don't actually need to do anything with it on that one. It may actually be, I'm getting back in the habit of this. These are actually the first examples I've worked out. I'm doing this before I've done it with you guys. Usually you want to get the configuration information before you continue, just to remember it and make sure you don't forget. This one's on carbon 1, and there's 2 hydrogens attached to it. So we don't actually have to put any identifier for it. It's just on position 1. You don't need EZ or Cis-Trans for it. But the other one has to have it. So we're going to go 1, 2, 3, 4. And looking at what we've got attached there, I'll get my brown again. On this side of the double bond, this side right here, this side right here, we have a carbon and then a carbon. This carbon is attached to hydrogen, hydrogen, hydrogen. This carbon is attached to carbon, oxygen, oxygen, carbon, because you want to go in order of highest atomic number. So this side definitely wins. This side over here is a carbon, then a carbon, hydrogen, 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 carbon, hydrogen, hydrogen. This side wins. They are opposite sides, so this one would be an E configuration. Now again, you not only do you not, you literally can't give a configuration for this. It's not E or Z, it's not cis or trans, it is just a double bond. So what we're actually going to do is we're going to go 4E, and then remember hept 1,4-diene 3-one. This is our base identifier for double bonds and then our functional group. So we have to do the 4,5-dimethyl first. So it'll be dimethyl, hept, it would be heptane, but it's now going to be hept 1, 4 diene, but we don't add the extra E at the end. If you do, I'm not going to count off for it, but technically it gets replaced because our new ending is actually going to be diene3. So 4E, 4,5-dimethyl hept 1,4-diene3-one. I know it just sounds like I like short-circuited and started saying like prefixes and numbers and stuff like that, but that would be the name for this structure. All right, last one, and get this scooted up. I'm going to kind of try to do this a little bit more down because I've got a, actually let's do, get that tilted up. There we go. We'll do it like this. Okay, this one looks really scary. It's drawn really weird, so we're going to have to try to figure out what's actually going on here. So let's first, because it's going to be a big one, we've got a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon chain. So 10 carbons is a deck. But we've got double bonds. We have 2 double bonds that are showing up in here. So it'll be deck 2 double. So now we need to get our actual numbers for this though. And if we look, so we're going to number from this direction or this direction. We have something on 1. Then we also have something on position 2. Then we also have something on position 3. We don't have anything on position 4. It's not until we actually get all the way into here that we have a point of difference. Right here is the difference. So we are going to number from this direction. So we've got 1, 2, 3, 4, 5. Because this direction would be 1, 2, 3, 4, 5, and would only have a single line. This one has 2 lines. That's the only real difference. It looks kind of scary and it's drawn weird, but this is actually completely symmetrical up to this point. So we're going to have to number from that side. So 6, 7, 8, 9, and 10. Remember, these are nitrogens, they don't count. These are oxygens, they don't count to the parent chain. So our double bond is showing up on carbon number 3 and number 7. This time I'm not going to forget it until the end. We're going to go ahead and identify them right now. So both of them are only carbons double bonded exiting with a carbon. There's not extra groups attached to any of the other sides of the double bond except for the parent chain. So we can actually use cis-trans isomerism for this one. So looking at the first one, we're going to do the rock finger thing. And we're going to go ahead and set it up there. So that one does match up with that bond. So the first one is going to be a cis bond. It does not match up with the second one. I can't get my fingers to bend that far, so it's got, the second one has to be a trans configuration. Remember, you don't actually have to put numbers for cis-trans isomerism. It's assuming the molecule is simple enough you can use cis-trans that you're just going to number it from the beginning. Okay, now let's group together. We've got these guys, this guy, and this guy are all the same. So that's 1, 2, 3, 4, 5 methyls. That's on carbon 2, 5, a second one on 5, one on 6, and one on 9. And that'll be pentmethyl, or you could do pentamethyl. Either one I would count. So that's pentmethyl. And then we've got at the very beginning here, this was an amine earlier, but now it's attached to a double bonded oxygen on that carbon. So these are actually going to be 2 amides, 1 and 10, so it'll be diamide. All right, now let's put it all together. So these identifiers, cis-trans, easy, all that stuff, always goes to the very, very front. So we're going to go ahead and do cis, comma, trans, close parenthesis. Then our deck, our double bond information, our diene, and our functional group identifier goes at the end of it. So we got to use our pentamethyl first. So it's going to be 2, 5, 5, 6, 9 pentmethyl. And then it looks like I'm going to run out of space, so I'm not even going to try to squeeze it in there. I'm going to go ahead and do a little arrow, and we're going to restart it down here. Then we have it as a 10 carbon chain, so it's deck 3,7 diene, because it's 2 double bonds, one at 3, one at 7. First one is cis, second one is trans. And then we're going to add in our 1,10 diamide. Okay, so I mentioned this at the beginning of the chapter. You can probably see part of why this could be the wall point. This is the point where, as I yawn at the ease of this, this is the point where a lot of people start going, this is a whole lot of information, because you're really building upon the stuff that we've already been doing. So if you have any questions about this, let me know. If you need any more examples, I'll make sure that I've got some on the review sheet. I've got those 2 worksheets you can be working on. We can work out extra ones on review day and class. In the meantime, I hope you have a good rest of your day, everybody. This is Mr. Diamond signing off.